now we need to work on a position time graph, and how we're going to do this is that it's similar to calculating the total displacement, but we're going to make trapezoids. We're going to divide it into two sections of 2 seconds each, 10 seconds of 10 sections of 2 seconds each, and then we're going to split it up, and then we're going to calculate the area under the curve in each of these sections in order to find the coordinates for a position time graph. And if we do it correctly, our final y value will be equivalent to our displacement. So let's start with section 1. We have 2 and then multiplied by 5.54, and the area is 5.54 times 2, but then we have, since it's a triangle, we have to divide it by 2, and that gives us 5.54. And then this triangle is going to keep on appearing throughout, and then we can just, now we already know that this triangle's value is 5.54, and then now we have the 2 width and then the 5.54 height, and then we can multiply those together in order to get 11.08. And now in order to find our coordinates, what we need to do, which is very important, is that we're not using this area as our y value. Instead, we're adding it to the previous y values. For now there's only 2. We're going to add these two together in order to get our y coordinate, and this is important because we need to find the total area, not just the area of this section. Ultimately, our goal is to find the total area underneath the entire curve in order to get the coordinates for a position time graph. So now we just continue this process. 2 times 11.08. As you can see, the rectangle, we're splitting this trapezoid up into a triangle and a rectangle. As you can see, the triangle area stays the same, it's 5.54, but the rectangle, the height increases by 5.54. So here was 5.54, now it's 11.08. And we're just going to systematically multiply these two together in order to get the area of all of these trapezoids, and then we're going to find our coordinates. So once again, 11.08 times 2 plus 5.54 times 2 over 2 equals 27.7. And then once again, we're adding this area value we get to all our previous y values. So now our coordinate is 649.86, and this is increasing exponentially if you notice that pattern. So we just keep on continuing this process. Now it's 16.62 as the height, and then we keep on calculating this. The 5.54 represents the little triangle at the top. We keep on calculating, we get 38.78. We add it to the previous y values, and then we get 88.64. And then we keep on doing this. We keep on doing this for all 10 sections that we've sort of walled off at this point. And as you can see, the areas we get, we're adding it to all the previous areas, and systematically this y value, this y coordinate, is increasing exponentially. It's increasing by a larger amount every single iteration. So we keep on doing this again. Now it's 27.7. Calculate this, 60.94 added to the previous ones, 199.44. And then this triangle, this trapezoid, 33.24 is the height, times 2 plus 5.54, the triangle, 72.02, and we get 14,271.46 as our y value. And we keep on doing this for the 8th section, meaning the t value is 16 since it's divided by 2 seconds each. And then now we have 354.56 as our y value. And then we keep on finding these areas and we add it to all the previous y values to get our new y value, 448.74, 554. And then ultimately we take all these points that we just calculated by finding the areas underneath, and then we make a graph. So this is our final position time graph. So as you can see, the values start small, but the gaps between them get bigger and bigger. And it's essentially, we can see it all on a graph right now, so this is an exponential function. This is increasing exponentially. So this is our final position time graph.